This little tutorial is how to do some soldering and especially tinning the printed circuit board for your project. You'll need some solder, rosin core solder 6040 is what we have in the electronics lab. We need some rosin paste, some components you plan to solder in, a pair of cutters. We'll talk about cleanup later with a special soap that I have to remove heavy metal from your fingers. And then a soldering iron station. Now this has been turned on and warming up. Usually sitting between position 3 and 4 is a good place to start. When you sit down to the station, you might want to make sure that the little set screw that holds the solder tip in place is good and tight. Sometimes they loosen up from the heating and cooling process. A wet paper towel is used to clean off the soldering tip. Sometimes you might need to take a little abrasive paper and gently scour that tip. The minute you do that, tin the tip, and you'll see that the solder flows on there nice and smoothly. If the solder vaporizes, that usually means the tip is too hot. Back it down a little bit. If the solder doesn't melt, turn up the heat just a little bit, maybe a half a number, from 3 to 3.5, something like that. And you'll figure out exactly where that temperature needs to be. With the printed circuit board, because these boards are fiberglass material with a laminate of copper on there, they first need to be cleaned. In industry, they'll take and clean this with a very, very toxic and strong acid. We're going to use a low-tech approach, just a piece of abrasive paper. And when you're done, this printed circuit board should look like a shiny new penny. I'm only going to do half the board just so you can see what's going on there. And once you do that, try not to handle the board anymore, because oils from your skin will get on there and will impede the tinning process. Sometimes it's good just to take a dry paper towel, wipe off some excess particulate that may be on there. Okay, now with the dry paper towel, you'll apply some rosin core paste flux. It looks like this. And a little bit goes a long way, and it can make a mess. So just be careful. And just a very light coating on what we're going to tin today. Sometimes it's good to wrap that up so that doesn't get in our way. All right. At this point, we're going to see if this board is going to accept solder, and we can tin those tracks, and the little holes where the leads come through are called pads. You have to make sure you transfer heat from the iron to the pad and the track. Now notice I have so much solder on the tip here that I've covered up those pads. That's okay. As you use up solder for the other tracks, you'll go back, grab some of this extra solder, and just cover the copper so there's no copper color left. Sometimes you can stick the iron tip in the paste flux, add just a touch more solder, and again, all we're trying to do is cover up that copper. If you go too fast, the copper won't transfer. If you stay in one place too long, it's possible that you'll cause the copper track and pad to lift off the board, which you don't want to do. Notice, you don't want a big buildup. You just want to cover the copper. Just want to protect it from oxidizing, just like a penny would in your pocket. As I said, I'm not going to do the whole board. I just want to give you the basic idea here. The tip will get contaminated with excess residue. Just clean the tip off, wet paper towel, and go back and tin it again. Okay, now, when you begin to insert components into the board, my strong suggestion to you is to use components that are not heat sensitive. Resistors, not terribly heat sensitive. Capacitors, these are disc capacitors, these are electrolytic capacitors, not terribly heat sensitive. Do those first. This way, as you get better at soldering, when you get to the more delicate components, you'll be able to do those effectively and efficiently. You'll notice the tape and cardboard on some of these devices. That's because these were designed for a spool and automated equipment manufacturing, where a machine would actually put these into the board. I'm going to use a resistor first and bend the leads in an approximate U shape like so. And since I don't have the schematic in front of me, basically I'm just going to select two convenient holes here. You'll have to make sure you put the resistor and every component in the proper location. Resistors, capacitors go flat to the board. This is called the component side of the board. This is called the foil side. Once you get it in place, bend the leads over. Again, always good, clean the iron tip and immediately tin it again. Now, for the soldering process, it should take no more than 3 seconds. And you want to be sure to preheat the junction, lead and pad on one side and add solder on the other side. So as I preheat this, I'm going to say 1 1000, 2 1000, 3 1000, and I'm done. Let me try the other one. Preheat the pad and the lead, add solder 1 1000, 2 1000, 3 1000. And you'll notice nice and smooth and shiny. And once we're done there, clip off the excess residue. And these leads can sometimes shoot in the air, so just be careful you don't point them at anybody. And that's how you solder your board. When you're done, make sure you return everything back to where it belongs. And most importantly, clean your hands at the sink area using soap and water. This is a special soap I learned about that's used by a friend of mine, his wife, who does stained glass work. And there's an awful lot of lead used in a stained glass process. This soap, which happens to be gentle on the hands, will also remove heavy metals, including lead. So before you leave the lab, make sure you wash up completely. Thank you.